operators who are in the room right now, Amanda Higgs, Rich Pendleton, also Dwayne Fox, and many others. The Atlantic sturgeon spawning aggregation near Hyde Park, New York has been very well localized. We know exactly where it is. So in 2021, as a pilot to our current NEARS study, we deployed an acoustic monitor, an acoustic recording device right within the Atlantic sturgeon spawning aggregation. This was a Soundtrap 300, which is a calibrated device. We put it out and recorded mostly continuously over the course of a month, which was aligned with their kind of peak spawning activity. And our first kind of step when we get back the acoustic data typically is to visualize it. And so we might use something like this, which is called an LTSA, a long-term spectral average. This is just like a spectrogram, just for longer periods of data. The spectrograms we were just looking at were for a couple of seconds. This is for a week of data that we're seeing. And there were immediately some things that we could recognize just what they were, namely geophony, such as environmental noises of rain or of wind. That's what this event is here. There's a lot of boat and mechanical noise at this site because it is very adjacent to the Poughkeepsie Yacht Club. So unfortunate, but that's just how it is. You'll also note these very periodic signals here. This is the daily chorusing of lots of male freshwater drum simultaneously advertising for mates, which was an interesting find because these have not been coming up in the gillnets at this site, but they're there apparently. And then there's also all these little very low frequency sounds, which we were pretty excited to see and dove in quite a bit more detail. And we found these little discrete rumbles. Are you actually seeing my cursor? Oh, no, not at all, sorry. Yeah, so each of these little rumbles that the arrows are pointing to down here, thought these looked quite promising and had features which were very similar to those which were reported for Lake Sturgeon thunder. Now we'll try this sound. So what you're hearing is both the continuous kind of band of energy, which is a bunch of freshwater drum chorusing all blending together, and then that was just another rumble. And so we're coming up on the third one. They're very low frequency, which is hard for us to hear and also actually hard to project at any volume, but they also are received at fairly low amplitudes. So I started annotating these, which means that I used visualizations of the data to literally draw boxes around these calls as I found them. But they were quite numerous at times, so it would take me about a day of effort to get through a day of audio data, which you can probably see pretty quickly. It's not really a viable approach when you're planning on collecting data for months on end at many sites up and down the river. So we needed an automated approach. Enter convolutional neural networks, which are kind of the go-to approach for automated detection and classification these days in bioacoustics workflows. I had manually annotated about 1,200 sturgeon thunders or putative sturgeon thunders at this point, and I said, okay, that's probably a decent number to start with training and testing. I used the Cuckoo package in Python to train a simple network with 5 chunks, which consisted of convolutional layers and downpooling and fully connected, etc. I'm happy to talk about nitty-gritty of machine learning with anybody who is interested in it, because I spend a lot of time thinking about this. But for now, the important thing is just that what this detector outputs are tables that have the start and end time of each thing that it identifies as thunder, a label, and also a confidence score. This is what some of the output looks like. You can see each of these boxes drawn around the thunder. That's where my detector returned something and said, I think this is what you're looking for. The accuracy metrics shown here look really great. Anybody who's worked with these kinds of models before are probably familiar with the fact that this is a very one-dimensional view of the performance of such a classification model. The fact is I'm getting a lot of false positives, but I can mitigate this by requiring a really high confidence score and just kind of disregarding anything that the classifier was like not as certain about. So what I did is I reviewed about 1,500 detections with a confidence score equal to 1, and I found that among those about 9% were actually false positive, which I thought, okay, that's a decent starting point. I can deal with that. And so then I deployed this model on this month of data from this site. I did a little bit of cleanup and I identified calls that were high signal to noise ratio and which didn't have a lot of other noise going on in that same frequency band at the same time. And I calculated some features and some statistics of those features across a whole bunch of calls. And then we get this. So on the left side here, we have the power spectrum of the average sturgeon call, the average putative sturgeon call collected from this site. You can see that the peak frequency is just over 40 hertz. They're not very wide overall. That's what the bandwidth, the negative 10 dB bandwidth is referring to. So the energy is pretty concentrated in a narrow frequency band. And the duration is typically on the scale of about 2 seconds, but sometimes we get quite a bit longer ones. You can see they go up to like 4 or 5 seconds. And I looked also a little bit at the temporal and spatial patterns, with the understanding that this is 1 month of data that I'm looking at right now, so we can only do so much for these temporal patterns. On the left side, I have 2 different plots representing the diel periodicity of this call. The top plot, each row is a day, and on the x-axis, we go from midnight to noon to midnight again, just right through the hours of the day. Each tiny little blue line represents 1 minute that had at least 1 thunder present in it. And then the shaded gray bars on either side represent the nighttime, and the little bit of pink on the top and the bottom is where we didn't have the recorder on yet, so that's not on effort. This kind of plot can be really great for looking at diel patterns and also seasonal patterns when you have more than 12 days of data that you're plotting. But it also, since each bar only represents presence or absence of thunders, it's not sensitive to difference in number of thunders in each of those small time bins. So that's why a histogram like this can also be really a nice way to view things. So now we actually have counts of thunders received in each hour of the day. And you can see that according to that histogram, at least, there seems to be a pretty clear crepuscular preference for spawning time, with an increase just before sunrise and a bigger increase just before sunset. Sorry, you really probably can't see the axes on the histogram. On the left, we have sunrise. In the middle, we have sunset. And on the right, we have sunrise. So daytime is the left-hand side of the plot. That's the first 12 hours of the day. And then nighttime is the right side of the plot. It's not the first 12 hours of the day, sorry. It's all based around when the sun rises and sets. And then I've kind of scanned through our data from these other sites up and down the Hudson, and so far we've only observed these thunders right at this site near Hyde Park. We haven't heard them anywhere else in the Hudson, which A, kind of builds evidence for these being attributable specifically to the spawning sturgeon, and B, further suggests that this is a spawning specific sound. So it might not be super well suited to tracking their habitat use in other areas of the river during other behaviors, but it might be really well suited to identifying if there are other spawning locations that are active, which need further protection, or which could offer further opportunities for investigating the species. We have a lot of next steps. In order to better kind of clinch the species assignment, we're going to correlate number of sounds per unit time with number of uniquely tagged fish per unit time at this same site. We're also hoping to do some tank recordings down at the New York Aquarium. They have a number of captive Atlantic sturgeons. The challenge there is that we don't know if they're going to be engaged in normal spawning behaviors in the tank environment, but we'll at least give it a try. And ultimately, we want to characterize the phenology of Atlantic sturgeon thunder in the Hudson River and understand how it correlates with environmental variables, with human activity, etc. And then also, just so you don't think we forgot them, we are also looking into short-nosed sturgeon to see if we can use sound to monitor them in this region as well. All right. Thanks very much. I'm sorry I've gone over. Thanks to our funding sources. Many thanks to everybody who has supported this research, because it's been a lot of